You guys ever go to the deli counter anywhere and there's a little number thingy and you pull the number and it says number 12, number 13, whatever? You know when you're gonna come up because you know the order that natural numbers go in, right? You know that as soon as the lady calls number 11, you're the next one, right? So that being said, if numbers are in order, you can predict information about those numbers. So let's look at some numbers for a second. Say take 1, 2, 3, and actually I'm going to even do 0, -1. This is a list of 1, 2, 3, 4, 5 consecutive integers. Nothing special about them. 5 consecutive integers. If I say n is equal to 1, if I say n is equal to 1, then the order of these numbers, 2 comes next, right? What must I add to that n in order to change it from 1 to 2? What must I add to n if n is 1 in order to change that n to 2? Yep. So n plus, what did you just say, 1? Are you with me, Lee? If this is 1, then 1 plus 1 is 2. And what must I add to that 1 to make it a 3? Yep. So this represents consecutive integers. Because by increasing what you add by 1 each time, it just keeps going up by 1 each time. What if I said, again, n is 1, what if I wanted to get 0? How do I go back 1 based on what I have? Subtract 1, yep. And minus 1 then would be 0. And minus 1 would be 0. Very good. So this would be example A from 1, and this is B. This is the number preceding the 1. This is the number preceding the 1. Now here's where it gets a little bit scary. Write an equation that says that the sum of 4 consecutive integers starting with n is 66. So the word sum means we're going to add, right? Add. And what we're adding together is 4 consecutive integers, right? So here's the first one, added to the second one, added to the third one, added to the fourth one equals 66. So if they're in a row, right, they're consecutive. So you add 1, then you add 2, then you add 3 to get to the next one. What will the first one be? Since it says start with n, the first one is going to be what? N. Good. And if we have to add 1 to get to the next one, what will the next one be? N plus 1. Good. And what will the next one be? N plus 2. And the last one? So these are the consecutive integers that when you add them together, their sum is equal to 66. Those are the consecutive integers that when you add them together, the sum is equal to 66. We can actually solve it if we wanted to know what those numbers were. And we would find out what that answer is. Let's go on to how to understand if they ask about odds or evens. So consecutive odd numbers means odd numbers only in a row, right? 1, 3, 5, 7, 9. Those would be odd numbers, right? So let's just say 1 is the first one that I'm discussing. And I'm going to call that n. What is the next odd number after 1? 3. What must I add to 1, or add to 1 to get it to 3? Nope. 2. You would add 2. So n is 1. If you wanted to increase that 1 to a 3, you would have to add 2 to it. And how would I get up to 5 based on n? What would I add to that n to get it up to 5? 4, good. So this pattern shows consecutive odd integers. I'm going to blow your mind here in a second. Consecutive evens. And these are evens in a row. First even number I'm going to think of is 2. Let's call 2n. What is the next even number? 4. What must I add to n to change it from 2 to 4? Try again. It's not 3. It's 2. And the next one is 6. What must I add to 2 to increase it to 6? This represents consecutive even. So notice that this and this can both be utilized to create a string of either consecutive odds or consecutive evens. Why? Why does it work for both? Why does it work for both? If I have a 1 and I add 2, I get to 3, keeping it odd. If I add 2, I get to 5, keeping it odd. Consecutive odds. If I have a 2 and I add 2, it goes to a 4. If I add 4, it goes to a 6, keeping it even. Why does this pattern work for both? You would think that, well, you must add 1 and 3 and 5 to keep it odd. Well, the numbers don't work that way. If you have 2 and you add 1 to it, what do you get? Is that still even? If you have 3 and then you add 3 to it, you get 6. So if you start with odd or even, adding 2 and then 4 keeps the string odd or even based on what you started with. I promise you, you're gonna miss this if you do not pay attention to what it is you want and if you don't test what you come up with. I guarantee you somebody here is gonna give me, for odd, x plus 1 and x plus 3, and that's wrong. It's always gonna be x plus 2, x plus 4, because whatever you start with continues to stay odd or even as long as you continue to add 2's. Okay? Let's look at example 2. This is actually out of the textbook, page 76. Page 76 says, solve over the given domain. So they're actually giving you a list of possibilities. That's the domain. The sum of 3 consecutive odd integers is. Well, first of all, let's set up what 3 consecutive odd integers are. Here's the first one, n, added to the second one and the third one. What will the second and the third one be? These are odd integers. The sum of 3 consecutive odd integers. N plus 2 and, what's the last one? N plus 4. By the way, in this group, which one is the biggest and which one is the smallest? Can you tell? Lizzie, which one's the biggest and which one's the smallest? Yep. Yep. It doesn't matter what we say n is. N plus 4 will always be bigger. All right, so we're saying this is the smallest, right? The rest of the story problem says the sum of 3 consecutive odds is 100 more than the smallest. How would I indicate 100 more than the smallest? N plus 100. So, sum of 3 consecutive odds is 100 more than the smallest. The sum of 3 consecutive odds is 100 more than the smallest. We can solve from here by combining our n's. 3n plus 6 equals n plus 100. They actually give you what you can plug in, but you guys know how to solve it from here, don't you? What do you think you would do to find out what n is? Subtract. Hold on. 3n equals n plus 94. So now what do we got to do with our n's? What are we going to do with our n's? We've got n's on both sides. You can't divide anything. You have n's on both sides. You can't have them on both sides. We have to group them together. How? So we've got, this is a positive and this is a positive. What do you want to do?
Well, you add more, right?
Well, if you add 1, then you have 4n equals 2n plus 94. If you guys just said to add 1. Your goal is to have a variable on one side and an answer on the other. What can I do so that I have variables only on one side? This one's positive. Say again? Where are you going to move it? Okay, so then you have negative 94 plus 3n equals n. Still don't have an answer. Still don't have an answer. Here, I'll go to the next side. 3n equals n plus 94. Last year, we learned that when you have variables on both sides, you want to combine them, right? So if this is a positive, how can I combine it to the other side while eliminating it from here? This is positive, right? How can I eliminate it from this side? So what? The answer is not to add, because if you add n, you have 2n and you have 4n. Subtract n, yes, we did a ton of this last year, guys. Subtract n from both sides. Now that we've done that, that's why they give you the domain, in case you can't remember, but I thought for sure you guys would be all over this, sorry. So now that you've done that, you have 2n being equal to 94. Okay, because we subtracted from both sides, leaving us with that, which now when we divide it in half, you're going to end up with what, 47? If I do my arithmetic right. Which means the list of integers is 47. What's the next one? 40. What's the next odd integer? 47. What comes after 49? And what's the last one? 51. Remember what the question asks for. What are the 3 consecutive odd integers whose the sum is 100 more than the smallest? If you add all these together, the sum is 147. Not that that's extremely exciting and interesting. Another way of doing it is the way they showed it there, is to actually test and plug them in. And I just think that's tedious, because here's how it would look. N plus 2 plus n plus 4 is n plus 100. And they gave us 3 numbers to test, right? So they said the options are 27, 37, or 47 for the first number. You guys see how they gave you the domain? So this is just solving it outright. This is testing. So if n is 27, then it's 27 plus 27 plus 2 plus 27 plus 4. Does that equal 27 plus 100? I don't know, you'd have to get your calculator out. 27 plus 29 plus 31. Does that equal 127? 27 plus 29 plus 31. Does that equal 127? So that's false then. That means this does not equal that. Let's test the next one. 37 plus 2, which is 39, plus 37 plus 4 is, does that equal 37 plus 100? True or false? True or false? False? Okay, sorry, I couldn't hear you. And the last one, 47 plus 2, which is 49, plus 47 plus 4. Does that equal 47 plus 100? True. So I just took the normal algebra that we learned and used it to solve. Whereas if you don't remember how to do this kind of stuff, you can simply plug in the domain that they gave you. They said the answer is either going to start with 27, 37, or 47. And if you plug in the domain, you'll find out that that's your answer right there. That's how you're able to solve it. Now for your assignment today, all they have you doing is writing an equation. All you're doing today is writing equations. So based on what you're reading, you're writing an equation, okay? And for 1 through 11, you have the answers in the back, of course, so you can check yourself.